For this problem, we're asked to find vertical asymptotes. We're looking at problem 8 of section 1.5 homework. So the first thing that you would do in a college algebra class when looking for the asymptotes is you look at where is that denominator equal to 0. Okay, so we see that the denominator is going to equal 0 for values of t that make t to the 4th minus 1296 equal to 0. And this is going to happen when t squared minus 36 and t squared plus 36 equals 0. I like to solve via factoring, but you can use other methods. T squared plus 36 never equals 0 for all values of t. This t squared minus 36 factors to be t plus 6 and t minus 6. And so that does have values to which it equals 0 that we can see that's going to equal 0 when t equals 6 and t equals -6. So those are the two values that we want to consider for potential vertical asymptotes. And then we want to look at, is it a vertical asymptote or is it a hole? Now, if you're wondering why in your algebra course, you could just make the assumption that if you had a place where the denominator was undefined, we automatically said it was a vertical asymptote. That theorem is given in the form that, it says you have to have the rational expression reduced. We aren't necessarily going to make that assumption here. So we've got these two values, and just to save space, I'm going to kind of move apart all of this. Kind of retain that factored form, though, if you have that on your piece of paper. I'm just trying to save board space, but you can hold on to that because we're going to reference that piece of paper here in a second, or that part here in a second. So when I look at the limit as t approaches, to determine are these holes or are they vertical asymptotes, is the limit defined, in which case we have a hole. And if the limit's not defined, or if the limit's going to infinity, we have vertical asymptote. So I look at what's happening as t approaches 6. Now I'm going to do this a little bit faster. If you get stuck, feel free to pause the video and kind of evaluate the limit using some previous techniques that we've talked about. I'm going to factor out a t, I get t minus 6. And then in this denominator, using what I just erased, we've got that t minus 6, that t plus 6, and that t plus 36 for that factored form. So the t minus 6's will cancel. And we get the limit as t, should have probably moved this over, as t approaches 6 of t over t plus 6, t plus 36. Okay, and then we can directly substitute 6. So I have 6 over 12 times, that should be a t squared. 12 times 72. Oops. Okay, so then that 12 times 72, that if we leave it factored, it reduces a little bit faster. We end up having common factor in the numerator and denominator of 6. So I have really 2 times 72, or 1 times 2 times 70 is 140, and then 2 times 2 is 4, so we get 144, 1 over 144. But the main thing that we need to take out of this is that limit exists. All right, so this limit exists. So what that tells me is that we have a hole at the value of t where t equals +6. So it's not a vertical asymptote there. Okay, so what's the other situation for a vertical asymptote that we need to consider is what happens when t equals -6. So when t equals -6, the limit as t equals -6 of t squared minus 6t over t to the 4th minus that 1296. What we see very quickly is it's defined in the numerator. You know, we get 72, but when I directly substitute that t to the 4th for 6 to the 4th power, we get that 1296 and we get 0 in the denominator. So right away I see I have this indeterminate form. So then I'm going to break it up and I'm really going to look at, well, what happens as t approaches 6 from the left of this t squared minus 6t all over t to the 4th minus 1296. Now we can use some of the stuff that we use up top. And so that tells me that this is going to then equal the limit as t approaches 6 from the left of t over t plus 6 t squared plus 36. And this should be a -6, right? -6. That was explain why it was not working. But we end up still with that 0 in the denominator. But let's kind of look at that. I'm going to switch colors here. This t plus 6, that factor I'm really concerned with because, you know, that t, okay, directly substitute, we get a constant -6. This we'd have a constant as well. So you kind of think a number. Okay, but what's really happening with this t plus 6 term as we input different values, as we look at approaching -6 from the left? So approaching -6 from the left, we're looking at negative values that are just slightly, you know, their absolute value, their value is going to be negative. If we add values like -6.1, -6.01, you know, these are going to be just slightly, you know, they're going to have outputs that look like -1/10, -1/100th, etc. And so we have a constant. When you think about that, we have a constant divided by a constant times, really this is going to be like a -1 over, or a 1 over -infinity. And so as a whole, what we should see is that this is going to approach, you know, this, even though it is 0, that dividing by a negative, those constants we're not really concerned with. They don't affect the value or the growth of it. This is really going to go towards that -infinity. Okay, so what that tells me is that this, if I approach it from the left-hand limit, it's going to equal -infinity. And if I look at the limit as t approaches -6 from the right now, I'm going to kind of fast forward ahead of t plus 6, t squared plus 36. And then we have, you know, that, again, we're looking at that constant over constant, and then what's happening for that t plus 6? Well, because, you know, -6 plus 6 is 0, we're looking at just slightly things like -5.9, -5.99, just slightly below that. And when we add it to 6, this is really going to be a positive, you know, like a +1 for 1/10, or really like 1 over infinity, but it's positive. And so this is going to approach, when we take that constant divided by a constant divided by that 1 over infinity, it's going to have that, it's going to approach infinity form. And so what we see is that we have a vertical asymptote at t equals -6, but again, that t equals 6 is a whole. So that t equals -6, that line, we have that vertical asymptote. We do want to put in the t there and the -6.